Okay, question 12. Place the following integrals in order of size, starting with the smallest. Okay, so we have three integrals, p, q, and r, yeah, and they both go from 0 to 1. They both go, the three of them, not both, the three of them go from 0 to 1. Okay, but then the inside is different functions, yeah? Okay, so how do I compare the sizes of integrals? Okay, now the ideal situation, yeah, which is not always the case, but the ideal situation that, okay, if let's say f of x and g of x, let's say f of x is always greater or equal than g of x for x in the interval a and b, say, yeah, then we know that the integral of fx from a to b, well dx, is greater or equal to the integral, right? I mean, this is intuitively true, right? Because if you imagine a certain graph like this, so this is f. Well, let's say g is somewhere here. This is g, for example. Well, then it's, well, okay, I swapped my f and g, I suppose. So this is f and this is g, because g is a smaller one. Then the integral of f is bigger than the integral of g, right? Because of the area under the curve. Yeah. Okay, so now, using this theorem, then we can actually distinguish p, q, and r. Yeah, we're lucky enough that f is completely bigger than g. So, for example, we can compare q and r first, for example. I think that's an easy comparison. So 2 is greater than root 2, right? So if I put it to the power x, no matter what value of x I take, this is going to be a strict inequality there. Well, except that x equals 0, so maybe, I'll put the equals on. Because when x is 0, both are 1. So, okay, how about p? Where does p lie? Well, we know that x is between 0 and 1, right? So if x is between 0 and 1, and you take the square root of x, yeah, the square root of x is bigger than x, right? The square root of x is bigger than x, so therefore, 2 to the square root of x should be bigger than 2 to the x, right? Because the exponential function is increasing, right? So therefore, the inequality sign does not have to change. So therefore, now I have an order of all these functions, with one completely above the other. Then we can use the theorem that I just said. Right, so this is p greater or equal to q greater or equal to r. Yeah. Okay. So therefore, answer would be, can't find it. Where is it? It would be f.